So today we'll be discussing questions from circle that were given in the practice session for practice. These are the basic theorems that we need to revisit. Just go through it once or write it down again. Fine. Now let's move on to the problems. We'll not waste discussing the question for a long time because these questions were given. The point O is the center of the circle circumscribed about triangle ABC with angle BOC equals to 120 degree. Angle AOB equals to 140 degree. What is the degree measure of angle ABC? This is the most easy question of this entire set. Just look at this. This is the diagram. There's a problem. Point O is the center of the circle circumscribed about triangle ABC. Okay. That happens while using GeoGebra. This is A, this is B, this is C, this is O, right? So the circle is circumscribing a triangle. Angle BOC equals to 120 degree. Angle AOB equals to 140 degree. Angle BOC is equals to, it is given 140 degree, and angle, what was angle AOB? Angle BOC 120, right? AOB 140. Okay, fine. This is 120. And angle AOB is 140 degree. And what do we need to find out? What do we need to find out? Find the degree measure of angle ABC. Okay, very easy question. Just if you remember the formula, not the formula, even the very basic theorem. Just look at here. Perpendicular terms from equal chords for circle equidistance in the same circle or equal circle. Angle subtended by the arc at the center of the circle. Yes, this property. Angle subtended by an arc of a circle at the center of the circle is twice the angle subtended by the same arc at any point on the remaining part of the circle. So this is the basic thing. Then only you can solve. We need to find out angle ABC. For that, let's find out this angle. What will be this angle? The measure of an angle around a point, this total angle is what? 360 degrees. This total angle is 360 degrees. So this will be 120, 140, 260 subtracted from 360 gives 100 degree angle, right? So this is, if this is theta, this is 2 theta. 2 theta equals to 100 degree, means theta equals to 50 degree. 50 degree is the answer. 50 degree is the answer. It's very easy question. That's very easy question. Those who haven't seen the problems, they need to go through the problem because these were given in the classroom. These questions. This is a very nice problem. This is a very nice problem and probably the best problem. We'll do this at the last. Now this is again easy problem from Singapore. 3 sides of a radius are arranged with the respective center A, B and C in a row. If the line WZ is tangent to the third circle, find the length of XY. You were even having the diagram, so this is not a great deal for you. I know the diagram is not clear at all. I think I'm having the diagram. Just a minute. Yes, I'm having the diagram. See, this is a more clear diagram. This is the given condition. Let me go through the given condition once more. 3 circle of radius 20. Okay, only radius. Find the length of xy. Find the length of xy. Only radius is given. Fine. Radius of the 3 circle. Radius of all the 3 circle is given. This is 20. We need to find this length. Okay, this is x. This is y. If it's not visible, this is z. This is w. This is a. This is b. This is c. We need to find this length. So how we find seems very difficult, right? What is this length? 40. Since radius is 20, diameter is 40. What about this length? This is also known. This is also 20. This is also 20. And what about this length? This is also 20. So we can just apply similarity here, right? Say, let us drop a perpendicular there, ABC. Let it be P. Let me name it as P. So what will be the length of WC? 40. This is also 40. And this is 20. 40 plus 40 plus 20, right? Which is equals to 100. And this is 20. Now we can apply similarity over here. What about WB? What about the length of WB? 40 plus 20, 60. Applying similarity, we have PB over 60 equals to 20 over 100, which will give you 5.6. $65. This is 5. 5 over 60, 12. You will get PB equals to 12, right? We will get PB equals to 12. Now I have the length of PB. Just let us focus on this circle. We have the length of PB. Let me erase all this thing. You have the length of PB, which is equals to 12. You have the radius of each circle, which is 20. You can easily find out the length of XP, right? Root over of 20 square minus 12 square. And this is a famous Pythagorean triplet. You know the combination of Pythagorean triplet 3, 4, 5, right? We all know this. Just multiply 3 with 4. You will get this as what? You will get this as 20. This as 12. This will be 16. Without even any calculation, just by applying this simple idea of Pythagorean triplet. I'm not even calculating, though the calculation is also very easy. Just look at this. You are having this triangle. This is very famous Pythagorean triplet, 3, 4, 5. But if you're given directly in the question this format of 3, 4, 5, it's very easy for us to find out this. They will just multiply all the side by a factor x and give it in the question. These are the popular Pythagorean triplet that we all should remember. Another is 7, 24, 25, I guess. Another Pythagorean triplet is Another Pythagorean triplet is 12, yes, 5, 12, 13. 5, 12, 13. So they will multiply all the side by a factor x and they will give it in the question, so that it would be difficult for us to find out the Pythagorean triplet. But just remember this format. These are the very three common Pythagorean triplets. Just remember the famous, just go through Google, you'll get the famous Pythagorean triplet and memorize them. These are very important and crucial. Often direct questions are being asked. In Diophantine equation, you will see you are getting some kind of Pythagorean triplet, or in anywhere you can get this Pythagorean triplet. So this is 16. So what will be the length of xy? This will be 2 times of 16. 32 is the answer. So 2 questions are solved. Let me look what are the questions left. Okay, let us move on to question number 4. This is a nice question again. Let ABCD be a quadrilateral inscribed in a circle with diameter AC. Okay. I'll give you a fake solving approach for this question, so that you can apply this in the objective exams. But this is not a good thing at all, but still we can apply this if you are having short stage of time. And often if you do not know how to apply it properly, you will not get the correct answer at all. But very often this is working. So I'll give you that ABCD be a quadrilateral inscribed in a circle with diameter AC. AC is the diameter. So angle subtended by diameter on a circle is what? 90 degree. And E be the foot of the perpendicular from D onto AB. Fine. There must be similarity because all are 90 degree, 90 degree, 90. AD equals to DC. AD equals to DC. That means these angles are 45 degree, right? And the area of the quadrilateral ABCD is 24 centimeters square. Find the length of DE in centimeters. Okay. This is a very nice question, but we can solve it with the objective approach in really a short span of time. We do not know anything about ABC, right? We know that this is only 90 degree. This is the condition. And D perpendicular. D is the perpendicular dropped from D onto AB. Now let me consider that ABCD is a square. Let me consider ABCD is a square. I am not having the diagram at this moment. And in this software, drawing the diagram is not an easy task at all. Okay, I draw a rough and diagram. Okay, let me use a circle from here only. There's so many circles. I'll use a circle from here. Okay, this circle. Let me use this circle. Let me use this circle. Just forgot about all these things. We'll use this circle for our. So according to the condition only, we'll draw everything. This is the diameter AC. This is the point D. This angle is 45 degree. But now we'll draw ABCD as a square. See, this is a very crucial step for solving the problem. This is also 45 degree since ABCD is a square. So what about this angle? This is 90 degree. Now what was DE? DE was the perpendicular dropped from D. DE was the perpendicular dropped from D onto the line BC, right? Onto the line BC, into the line BC. This was D and this was 90°. But look at this, that when I'm considering ABCD is a square, this angle is becoming 90°. So DA is now coincident to DE. So we're having the area of this quadrilateral ABC D, which is 24 centimeters square, and DA is the side of this square. So the length of D that we're supposed to find out is square root of 24, and this is the answer indeed. So this is a very good fake solving approach. This is not good for the exam, definitely. For mathematical point of view, this is the worst thing that we're learning, and I would refer you not to learn this kind of things. But while applying this, if you're applying by chance, how can we ensure that what we're applying here, we're making this quadrilateral, random quadrilateral into a square, and everything is satisfied? Just go through the criteria given in the question. If all the criteria given in the question are satisfied for this ABCD a square, for this ABCD, if all the angles criteria are being satisfied. Now if something was given like that this angle in the question is 30°, and you are considering that this is a square, then your answer would be definitely wrong. So just, or sometimes this may not be directly given that this is 30°. They'll give it in other format. Say they will give you the ratio, length or anything, and you need to go through a little bit of angle chasing to look on that whether everything is satisfied in the question or not, when you are considering that ABCD is a square. So this is definitely a dangerous approach, because if by chance anything is given in the question which results in any angle to be different rather than the square, then you will not get the correct answer. So the question setters, those who are making the question, they need to be aware to create the question in such a way that if someone is using fake solving technique, then their answer should never be correct. And these are the old questions. You can see question in 2009. So that time we can say that the exams were not so much developed. It's developed. If you look at the first question of the International Mathematics Olympiad, you'll find it easy. You may even solve it. So the old questions are not that tough. Just look at the first question of this AMC that we have given from 2007. A very easy question. But nowadays, when you are applying this fake solving technique, the question is being set in such a way that when you are applying fake solving, you will get a wrong answer. So do not apply this. Now we'll go through the subjective approach of this question, and we'll get root 24 as the answer. Very long approach. Very long approach. Sit with your 100% concentration. I'll make it a little bit fast. Just join BD. This is the first step. Let me go through the criteria of the question again. AD equals to DC. AD equals to DC. Nothing is given other than this. E be the foot of the perpendicular. Fine. E be the foot of the perpendicular. AD equals to DC. Area quadrilateral. Okay, fine. So what about this angle? This is 45 degree, and this angle is subtended by this side. So the angle subtended by this, say, arc AD, minor arc AD, is subtending angle 45 degree. So the angle subtended by this will be 90 degree. Similarly, here you will get 45 degree. Just make a proper diagram and write all those angles so that we can approach the question a little bit faster, because I'll remove this. Okay, now let me remove it. So this is the first angle chasing that I can apply. Let me draw a clear diagram. Fine. This angle, this angle, this angle are equal. Nice. Just look at the interesting fact. Look at the interesting fact that the angle subtended by the minor arc CD, this angle and this angle, are also equal. So this is also. Now DE is perpendicular. Can we comment anything about triangle BED? Yes, we can. How we can? Because this angle is 45 degree, right? And this is lying inside triangle BED. So this angle will also be equal to 45 degree. All the red angle that I am marking are here 45 degree. This angle will also be equal to 45 degree, which implies that this side BE, side length BE, equals to side length DE. Just write it down. Write down the steps. I am not writing it. BE equals to DE. I am just marking the angle. You can write out the crucial steps. Okay. Now angle BAC equals to 90 degree. Angle subtended by the diameter. Angle DEB is also equals to 90 degree. That is, both are perpendicular. Both are mutually perpendicular. Not mutually. Both are simultaneously perpendicular to AB. Right? Which means that BC parallel to DE. Fine. This is the symbol for parallel. Fine. And we have BE equals to DE. Now we can easily find out the area. Yes. We can easily find out the area. Let me mark this as X. Say BE equals to DE equals to X, and try to compute the area in two different times. You will get a quadratic equation, and you can solve over here. I think you will get a sort of area of ABCD. Area ABCD can be written as area AED, area BED, area BCD. Fine. AED, AED, BED, BCD. area of ABC can be written as area of, just write area before that, I am not writing it. AED, area of BED, area of BCD. Fine. Now how can we express area of AED? See, this is very easy thing. This is X, so we can write area of AED as half into X into AE, that is half into base into height. A is the base here. Okay, let us write it in terms of, we'll get the same thing. We'll get the same thing only. Still, let us write AE in terms of, okay, we'll write it in the next step. Otherwise, you'll get confused. Half BE and D both are equals to X, B equals to D equals to X, plus half into BC into X. Now, in this step, we'll get confused that how we're getting area of triangle BCD as half into BC into X. See, this is B. Let us extend this and drop the perpendicular. Since BC is parallel to D, what will be the value of this X? This will be X only. And that's why you're getting the area as half into BC into X. Right? Now what we can write AE as? We can write AE as, AE can be written as AB minus X AB minus X. So we can write half X into AB minus X plus half X square plus half BC into X, right? Just add them up. This half X square from here, it will get cancelled out. This will get cancelled out. Will be left into half X times AB plus BC, and area of ABCD is given, which is 24. X time AB plus BC equals to 40, right? Fine. What we can write in another form, the area of ABCD. Oh yeah, just look at this fact. Area of ABCD can be written as area of ABC plus area of ADC. ABC plus area of ADC. Now just focus. I am drawing it here because this diagram I do not want to use it for rough work. See, this is D, this is O, and we do not want to know, neither we want to know AB plus BC, what we can do. BCCD equals AB into BC, right? Can we relate this AD into DC anyhow? Okay, yes. What is this length? This is the radius, and this is also the radius of the circle. So the area of this triangle will be half times of r square, and the area of this triangle will also be half times of r square. Adding them out, we will get r square. So area of ADC equals to r square. So again we are writing area of ABCD. Again we are writing area of ABCD. This will be half of, I need to write it elaborately, ABC plus ADC. And we've seen this will be half of AB into AC plus R square. Now let's try to find out the relationship between AB, AC and R. AB, AC and R. Just look at this. This is a right angle triangle. This is the hypotenuse. The diameter is the hypotenuse and the value of the diameter is 2r. So you can just apply Pythagoras theorem here. Pythagoras here. We'll get AB square plus BC square equals to 4 times of R square, right? Now we'll apply this relation, few relations that we are having in our hand to get out the value of R square. Just write out AB plus BC whole square. Why we're writing AB plus BC whole square? Anyone? Just look at this relation. We're having a relation between AB plus BC and x. We need to find out the value of x so we can easily find out the value of AB plus BC whole square. In order to find out x, this will be AB square plus BC square, that is 4R square, plus 2 times of AB plus AC. AB plus AC, 2 times of AB into AC. Now I can find out the value of AB into AC because this is equals to what? The area. What is the area of ABCD? 24. 24 minus R square into 4. 24 minus R square into 4. Okay, write it here. We do not need to give a step jump now. This is AB square plus BC square, right? AB square plus BC square. Should I write it here? Okay, let me write it down. AB square plus BC square. Now let us substitute in terms of R. AB square plus BC square is 4R square, and from this relation we can get 4R square 24. 4 times of 24 minus R square. R square cancelled out. We'll get here 96. AB plus BC. We'll get AB plus BC as root over of 96, right? Now we have this relation. That half of x into AB plus BC root over of 96 equals to 24. Find out the value of x. This will be root over of, this will be root over of 24, or you can write 2 root 6. So this is the total solution. Just have a look, go through it once. Let me zoom in. Fine. Now we'll move up on to the last question, and then we will solve the second question. So this is the last question. As shown in the figure below, circles C1, C2 of radius 360 are tangent to each other and both tangent to straight line L. If circle C3 is tangent to C1, C2, okay, figure is not on, we're not understanding the figure at all. Fine. This is the circle C1, this is C2, this is C3, this is C4. Now it's visible, right? As shown in the figure below, circles C1, C2 of radius 360 are tangent to each other and both tangent to the straight line L. If circle C3 is tangent to C1, C3, C3 is tangent to C1, C4, C2, C1, C2, C4 is tangent to, and circle C4 is tangent to C1, C3 and L. Find the radius of C4. Okay. So we need to go for some assumptions, right? So let me consider the radius of C3 as R and radius of C4 be small r, right? Now we can apply simply Pythagoras theorem. How and where? How and where? Let us extend it. Let us join the center. $360. So this is a right angle triangle, right? And what about this height? This is R. So this will be 360 minus R. This side length, right? Only this part. And what will be this? Any idea? Can you look at the symmetry? This will be 360, right? This will be 360. And what about the hypotenuse then? This is R. This is 360. So we can apply Pythagoras theorem over this triangle. 360 minus R, 360, and 360 plus R. We will have 360 minus R whole square plus 360 whole square equals to 360 plus r whole square, right? So just compute the value of r from here. Do the calculations, please do the calculations for me. Yes, definitely for me. A square minus b square formula. How much time do we need to do this calculation? Why are we so slow in these calculations? This is not the answer, right? We need to find out the small r. Okay, again we'll apply Pythagoras theorem. Again we will apply Pythagoras theorem over here, right? Here applying Pythagoras theorem is a little bit difficult task, I think. There is no such line of symmetry or anything else. This is 90, right? I'm just thinking how can I apply. Okay, the total length is what? 360. And if I again draw that symmetry, which is very much useful for me, we need to find out this length, right? Yes, in two triangle, if we apply Pythagoras theorem, we'll get our answer. Very nice, very nice, very nice. Let me draw a clear diagram for you all so that you'll be able to understand what's happening there. This is 360 minus of r. This is 360 plus of r. This is 90 plus r. This is 90 minus r. And we do not know what is the value of this, right? But again, if you can focus here, if you can focus, the total length of this segment is equals to the radius, which is equals to 360. So let me name this as A, this is B, this is C. AB plus BC equals to 360. Let us find out AB using Pythagoras theorem. 360 plus r whole square minus 360 minus r whole square root over plus bc 90 plus r minus of 90 minus r whole square, which is equals to the total length 360. Just go through it once, just go through the steps once if you want to understand. Solve r from here. Solve r from here. I'm not solving, I'm just give you the answer. R equals to 40. This is the answer. Solve r. Now we're left with the last question, which is definitely not the last. Means this was the second question, but we didn't solve it because this is a tough one. And this question is even the best question that we're going to solve today. The diagram of the question is based on so much good application that we can't even just go through the question 2 times, read the question 2 times. The adjoining figure shows 2 intersecting chords in a circle with minor arc 80. Suppose that the radius of the circle is 5, BC is 6. See, we are getting a Pythagoras triplet here again. This is 5, this is 3. We know that the perpendicular from the origin, from the center of the circle, divides the chord. So this is 4. Because BC equals to 6, right? Half of BC is 3. And AD is bisected by BC. AD is also bisected by BC. Suppose further that AD is the only chord starting at A which is bisected by BC. It follows that sine of the minor arc AB is a rational number. If this fraction is expressed as m by n in lowest term, what is the product of m by mn? Nice. So firstly, just go through the question once, try to solve it, and then resume. So I hope you all have tried and successfully solved it. The answer of this question is 175. Now let me solve it. When in the diagram, I'm having the diagram. Yes. It will be difficult for us to understand the diagram at the first glance. See, just focus on this. I'm highlighting. This is BC and this is AD, right? This is the center O. AO is joined. The circle with diameter AO is tangent to BC. The circle with diameter AO is tangent to BC. How? How this is tangent to BC? Fine. What about this angle? Say this is not visible. Just write down the diagram. Draw the diagram. Exactly the copy of the diagram in your copy. This is N, this is B, this is D, this is M, this is R, this is Q, this is O, this is P, this is A, this is C. Just look at this, ON. Yes, ON. Let me consider that ON is the perpendicular. Okay, would not. Let me prove that ON is the angle ANO is 90 degree. If angle ANO is 90 degree, to prove that BC is tangent to the smaller circle, let me name it as S2. This is S1 to S2. Prove that BC is tangent to S2 at N, right? How we will prove? How we will prove? O is the diameter. If we can prove that angle ANO is 90 degree, we can prove that OA is the diameter, right? And hence BC is tangent at N, right? So we need to prove angle ANO is 90 degree. How we will prove this? How we will prove this? Very easy. It's given in the question that AN equals to ND. We can join OD, right? So OD equals to OA equals to radius of the circle S1, say R1, and AN equals to ND, which is given in the question, and ON is common to both. Now using congruency, we can prove that ONA is congruent to, just write the steps in your copy properly, I am not writing in an organized fashion. ONA is congruent to OND, which implies that angle ONA equals to angle OND equals to 90 degree. ANO is 90 degree, which is proved. ANO is 90 degree means OA is the diameter, BC is tangent at N. So the first thing that my diagram is valid is proved. Just write it down so that we can move ahead. This is 90. This is 90. Okay, let's move ahead. Let's move ahead. Okay. What is the radius of this larger circle S1? S1, it's given 5, right? And at the very beginning, while just reading the question, I was just reading the question, I have shown you that this is equals to 4. So OM equals to 4, right? What is OA? OA equals to 5. OM equals to 5 times of OR plus RM, right? let me write it a different way. What is the length of this PN? If length of O is 5, this is 2.5, and this is also 2.5. Yes. Can we just observe that this QR equals to Pn? Yes, we can observe. So this is 2.5 plus 2.5 cos angle POM, cos angle POM. Equals to 4. Equals to 4, right? So we can find out cos angle POM. We can find out cos angle POM. Now, can we find out any information about angle BOM? Can we find out any information about angle BOM? Can we or not? This is 4. See, this is 4. This is 3. This is 5. Angle BOM is 37 degree, a very popular angle, right? We all know this. This is a very, in the problems in physics, this is a very common angle, 37 degree. Then this is 3, 4, 5, very common angle in physics. So we have angle BOM. We can find out the value of cos BOM. Find it out. 1.5. 1.5 over 2.5, 3 over 5. Okay, what's happening? Just a minute. If it's 3.5, then something is varied here. Something varied is happening. What is the length of OM? OM equals to 4. And nothing varied at all. Sorry. And thus tan of angle POM. This is very common angle, as I said just now. 345 will be 4 by 5, right? And we can find out tan of angle BOM. Angle BOM. I'm drawing it here, which is 4 by 3, right? 3 by 4. Now we need to find out the value of sine of angle AOB. Sine of angle AOB. Why we're doing in 10? We're doing this in 10 because subtraction of 10 is easier. Because when you're subtracting 10 or cos, you need to find out both 10 and both the values of sine and cos and then evaluate. So converting them into 10 and finding out the difference of the angle and then converting that angle into sine is easier task. Sine of the minor arc AB. Yes, sine of the minor arc AB. AB. Yes. So we are finding angle AOB. Sine of minor arc AB. You can easily find out angle AOM using this subtraction of 10. 10 of angle POM minus angle BOM equals to 10 of angle AOB, right? And writing is very clear, I know. So AOB, and you can easily evaluate the value of the sine. So this was the question, probably one of the most lengthiest question that we solved today. And after solving, we'll get m by n as 7 by 25, which is again a very popular triangle. So mn will be 175. This is m, this is n. So for today, this much only.